So, how you guys doing today?
Good.
Good, good, perfect. So, I think this is the last lecture. So, I'm gonna do the review again on the final exam, but will be comprehensive, but will be open book test with Canvas online exam. So, I also kind of recommend you guys go watch the exam 1 and 2 review. We will kind of need to. So, yeah, let's try some problem here. If you have this one. Okay, let's try this one real quick. About 1 minute, we'll do this. Okay, so yeah, here's the thing. So if you look at this one over here, this hydrox group is very poorly. So before we do the substitution, we gotta check with this one first. So when you do it, you become better living. Okay? And then whenever you have a bromine anion coming from the back, because it's SN2, so and whenever it goes to the back, meaning you're gonna have a bromo group, not on the front where you had an initial group, but on the back. So the answer will be the bromo group on this carbon base on the back, not on the front. This is SN2. Should be inversion of stereochemistry. Makes sense, right? Makes sense. All right.
Dr. Cho.
Mm-hmm.
So if that OH was just like a line,
Mm-hmm.
would it just turn into BR? Like,
Mm-hmm.
would it be the same like BR with a line?
What do you mean the line? Our line?
Like instead of the arrow, like instead of it being pointed backwards, if it was just BR coming off of the top?
Could you explain? I'm sorry.
I can.
Yeah. Oh yeah.
I can
Could you?
draw
Yeah.
it if
Yeah.
you want.
There you go. Argon line.
Like if it was just that
Uh huh.
and the same, would it just be BR with the line?
BR with the line? What do you mean the line? Oh, if there's just a line
Yeah,
there.
yeah, yeah.
Oh, yeah,
Instead
yeah,
of
yeah.
the arrow.
Yeah. Then it I-axis. Instead of the dash or wedge line.
Yeah,
Okay,
yeah,
okay. Yeah. In that case, you don't have to worry about it because it will be just you can replace as just this one.
Okay.
Because it didn't specify it's stereochemistry. But in here, actually, it's kind of good question. You don't have to do this because it's not stereochemistry. This is not Kyrie center. See, so I would, because those are the same one. So you wouldn't put wedge or dash there. It will be the same anyway if you flip it. But I put the integral in here, then it becomes the Kyrie center. Then you have to put either wedge or dash. If I didn't do that, you don't have to worry. This is.
Okay.
But yeah, that was a very good question. Okay, so maybe we can try this one. So this is the Grignard reaction we did in chapter 10. So Grignard was about R magnesium X could be the halogen. Oh, give it just 1 minute. We'll do this together. Okay, so here's the thing. So if you look at this one, has like a R. This is like an X, halogen X. So whenever you treat with the magnesium, they just do MgCl. So magnesium goes into between R and the halogen group. So it'll be just R, and just put Mg. And then what it does, this R, like magnesium X form, is this carbon here will be electron kind of richer because of the now not dealing with the halogen, which is electronegative, but it's metal. So this will be just compared to carbon, magnesium not so competing with it, possessing the electron density there. So what it does with the water is this carbon now can grab the hydrogen. Okay, so they just become cyclohexane, and they just leave like that. Okay. But the thing is, the simple trick you can do is whenever you have some halogenated compounds like here, when you treat with the magnesium and water, you just need to remove it. That's it. That's the trick. So whenever you have bromo groups, chloro groups, when you treat with the magnesium and water, you just remove that group. That's it. That's the problem. Make sense, right? Okay. That's it. Okay. This is a diorganal reaction. Okay. We can try. Try this one. Diorganal copper. Okay, so yeah, the diagonal copper, you just need to do this. Do you see this 2 methyl group on copper? Okay. Okay, and whenever you do this one, you look at this 2R form, R2 copper. Okay, just put 1R, not 2, just 1. So 1 methyl group will just switch your halogen group. That's it. So just look at the R group here, which is 1 methyl group, CH3. And whenever you see the halogen group over there, switch it to that 1R. Even though there are 2, it only goes to do 1. That's it. Okay. Okay, so this one. And there are 5 like solvent candidates, and one might be the best one for SN1 reaction. So you want to have S1 reaction. What might be the best solvent molecule among these 5 candidates? So you see the lines are all methyl group. Okay, so here's one thing. Oh yeah, you can see. Yeah, go ahead, copy that. Okay, so this is a chloroform. This is a hexamethyl, the phosphoramide, and this is the DMSO, the dimethyl sulfoxide. This is the dimethyl formamide, and this is isopropyl. So this will be number 5 because just remember for SN1, you need to have a polar protic solvent, meaning whenever you have a solvent is able to do some hydrogen bond, that is the best one. So either you have some compound with the hydroxy group, or amino groups will be the best one for SN1 because they are able to do hydrogen bond, but those are not able to do. So we call them polar aprotic solvent, which they're not able to do form hydrogen bond in solvent. So those polar aprotic solvent actually good for SN2, not SN1. Okay. You guys actually remember this one? Okay. Good. All right. So okay. Okay. Yeah. So what might be the most reactive compound for SN2? What might be the most reactive compound for SN2? So here's the thing. Whenever you need to look at the best compounds for SN2, you need to have a less bulkier compound is better. Because the SN2 reaction, you want your nucleophile coming from the back. But if you have a very bulky compounds, this won't be that easy for them to approach on the back. So if you look at this one over here, which is very good because you only have one carbon here, and this on the back of this carbon here. So this is pretty good, only one. This is also good, there's only one. over there. Okay. This is also good, only one over there. It's not bulky in this carbon here. But this carbon is your secondary, right? It's 2. So it's not so perfect for the SN2. This is awful because it's tertiary. Okay? So we have a tie on those 3, right? We have all primary on either chlorine and bromine and iodine. Okay? So one might be the best one among those 3. So if you remember the trend, if it's the bigger, it's down in the column, is the better reactive. So it would be number 3. Okay. So if you look at the column, chlorine, bromine, iodine, the downer in the column is the more reactive and SN2 because they're easier to leave because it's bigger elements. So if I change this one to SN1, what might be the best one for SN1 instead of SN2? Okay. And then this will be the best one, number 5, because it is a tertiary. So whenever you have a carbocation, when the leaving group leave, you have a very stable carbocation because it's tertiary. The carbon will be very stabilized with the positive charge because a lot of carbons around it. And then also you have a very good iodo group, which is very also good leaving group too. So that's perfect for the SN1. Makes sense, right? Okay. Okay, how about this one? What reaction this will be? Yeah. Just choose half. Yeah. So look at this one here and see what type of the reaction you're gonna possibly get from those 2. So you see this is water in ethanol with mixture a certain degree. Okay, so this is actually, there's a lot of hint over here. It's not tricky one because when you look at the water, which is not strong nucleophile because it's a neutral nucleophile. So it won't be good for SN2 because for SN2 you need to have quite strong nucleophile. But SN1 you don't have to have a strong nucleophile. A neutral nucleophile is okay for SN1. And also the base, your solvent will be water and also ethanol, which is also good for SN1 because it's a polar protic solvent. They're able to form the hydrogen bond. So this is also good for SN1. There's 2 hints over there. And also there's another hint over here, which is what? This carbon is tertiary right now. So SN2 cannot happen on this one, which is because they don't have a space to attack on the back. So it's gotta be either SN1 or E1 together. Okay? So this is the only possibility you can choose for this combination. All right, so the last one is this one. Okay, so try to remember the Jai-Sieve rule, okay, for elimination. Okay, this is ethanol. Is that the sign? So try to remember the Jai-Sieve elimination rule. There will be major and minor compounds, but which one becomes major, which one become minor, it depends on something. Okay, let's try to remember now. So in here, there's two possible scenarios. Either they can pick the hydrogen on the inner position or terminal position. So if we take it the hydrogen on the terminal position, you're actually going to have, so when this comes, hydroxide comes in, pick up this one, this goes to there to make a double bond. Okay? And then this will go leave. So this is gonna leave there. Okay? So this is one product you can have. Another one is they're coming onto this one. Okay? So they pick up the hydrogen and goes to an inner position and they leave. So they will become another product, which is here. Okay? So you have a two possible product from the elimination. But if you look at the position of the double bond, it's on the terminal position, internal position, which will have a more substitute alkene because there's two R on these two carbons and two hydrogen. But here it has only one R group, the three hydrogen on it. So it's a mono-substitute. So di-substitute alkene is more stable than mono-substitute. So this will become your major product. And this will become your minor product.
Is the one on the terminal position always going to be the minor one?
Yes, you probably right. Because when they pick up the terminal hydrogen, they form the alkene on the terminal position. It always less substitute than ones inside in the internal alkene. Yes. So you can think about the combination on your multiple choice in the final exam, and look at the one in the internal alkene. It will be your major. Yes. But the terminal one will be less substitute. Yes. So it'll be minor. That's very simple trick. Make sense, right? Okay. All right. I think that's all I have today. So I'll finish here, but